Okay, so today is like officially day 2 of lesson 3. Today what we're going to do is come up with the standard form or write equations for the hyperbolas. Yesterday we were given equations, and from those equations we had to find the focus, the vertices, the asymptotes, and then we had to graph them. So today we'll be given a little piece of information, whether it's an asymptote or a vertice, or a vertice and a focus, and then from there we can generate the equation. So let's go ahead and look at our first example. Now, as we've done this prior with the parabolas and the ellipses, sometimes some people need a visual, so they need a picture. You don't have to draw a picture. I could look at this right away and I can already tell that this is going to hit the x-axis. So my x squared term is going to come first. However, if it helps you to graph the given information, just so you can get a picture, you can do that. So let me just do a quick rough sketch here. I'm going to graph the two x-intercepts. They're both at the order pair 4, 0 and negative 4, 0. These are my x-intercepts, which, because they're touching the x-axis, these are also my vertices. Notice my center point is the midpoint here, and it's the origin. I also have a focus point, which is at 5, 0. So one more pass there. Remember, the focus point is going to be inside that hyperbola. So I can also figure out my C value based on the focus. So remember, the vertex, the distance from the center to the vertex gives me my A value. So notice that between green and blue here, there's 1, 2, 3, 4 spaces. I can also look right here at the order pair. So my A value is 4, so A squared is 16. The distance or the length between the focus in the center, that's going to be 5, because there's 5 spaces between the focus and the center. And that is your C value. And then we'll square it. So now, I also need to realize that because it's touching the x-axis or transversing the x-axis, okay, so because it's touching the x-axis or transversing the x-axis, my standard form that I'm going to be filling in is x squared over a squared. Remember, a squared is always first. It's always a subtraction sign when it's a hyperbola. And then the b squared is under the second, and it equals 1. So all I'm really trying to find out here is what a squared equals and what b squared equals. I've already found a squared, so now to find b squared, I'm using this equation or formula. C squared equals a squared plus b squared. So remember, with the hyperbolas, it's a plus sign. When it was the ellipse, it had a minus sign in this formula. So I'm going to go ahead and replace the c and the a. So c squared is 25. A squared is 16. I'm going to subtract the 16. And I get 9 is equal to b squared. I now have all of the information that I need to fill in my formula or my standard form of the equation. So it'll end up being x squared over a squared, which is 16, y squared over 9, and it equals 1. And that's the standard form. So we're not graphing anything here, we're just coming up with the equation. Let's try the next one. Okay, this time I'm given a vertice and an asymptote. Everybody good on example 1? Yes, question?
Can the A ever be like smaller than B or no?
It doesn't matter. It just is first. The A can be smaller. Yes. Okay, so here, again, if you want to get a quick little picture here, just to see which letter is going to come first, or you could just look at the order pair. Notice in my vertice, the number is in the Y spot, So this is telling me y squared will be first. Again, the a squared's always underneath the first, and then x squared and b squared. But let's graph these vertices. So I have one at positive 6 and negative 6. And it's on the y-axis. And then it's also giving me an asymptote. Now I could go ahead and graph it, rise 1, run 1, but really what I want out of the asymptote is my a and b value. So if you recall, when we learned this yesterday, when the y squared is first, the format for the asymptote is y is equal to plus and minus a over b. So already I can see that a over b is equal to 1/2. So here's what I'm going to do. I'm going to take a over b, and I'm going to show what's in the asymptote. Now remember, that 1/2 is the simplified a over b. Okay, so originally it's probably 6 over something that's simplified to 1/2. And the way that I'm going to find out the b value is I already have an a value from the beginning, because remember the distance from the center to the vertex is your a value, and I can see it right here, it's 6. So my a is 6, so a squared is 36. But what I'm going to do is I'm going to set up a proportion. I'm putting my a values in the numerator and my b values in the denominator. So both of the top numbers here are a values, and both of the bottom numbers are b values. So now that I've set up the proportion, now I can cross multiply and divide and figure out what b is. So I would multiply 1 times b and 2 times 6. So b equals 12. Now I know many of you probably saw, well, if it's the simplified fraction, what is going to have to be down here in order to get that fraction to simplify to 1/2? And you can see that it's a 12. But again, set it up as a proportion, because sometimes it's not this pretty. So you would cross multiply and divide. So now b squared is equal to 12 squared, which is 144. So again, I needed to find the value of a squared and b squared in order to write my equation. Good? Yes?
So a squared isn't always bigger than b squared?
No, not always. That's for the ellipsis. Okay, here a squared is just first. So a squared could be smaller. Yes. All right, so let's fill it in. So y squared over 36 minus x squared over 144 equals 1. Okay, before in the ellipses, a squared had to be the bigger number. Now, a squared is just the first number, and it can be smaller. We're going to try another one with the center at 0, 0. Question? Everybody good on example 2? Yes.
So the equation is y squared minus x squared? Always minus?
Yes. So for the hyperbolas, it's always a subtraction sign.
And for the hyperbolas, but for the other ones?
For the ellipsis, it's a plus sign.
And for an ellipsis, you know the c equals, is it a squared minus b squared?
Correct. So in the ellipsis, it's got a plus sign in the standard form of the equation, but in the c squared formula, that's a minus sign. Here it's backwards. The equation has the minus, but the c squared has the plus.
So the hyperbola is basically the opposite of the...
Mm-hmm. Okay, so let's try example 3. Again, if you want to draw yourself a picture, you can. Again, I can already tell that the number here in my vertice, it's in the x spot, so this is going to be on the x-axis. So I already know my standard form is going to be an x squared over a squared minus y squared over b squared equals 1. And this time it's passing through an ordered pair, 6, 1. So let's go ahead and just get a little visual here. So the vertices are at 1, 2, 3, and 1, 2, 3. So at positive 3, negative 3. And then it also goes through the ordered pair 6, 1. So right here I can see that it's going to look like this. So it's touching the x-axis. So that's why I put the x squared first. Now again, my center here is at 0, 0. So I can already calculate my a value. I can see that it's 1, 2, 3 spaces away. So a equals 3. A squared equals 9. Now, I don't have a b squared value or a c squared value. So using the formula c squared equals a squared plus b squared isn't going to help me here. So instead, I'm going to plug my information that I have right now into this red equation I have here. Because remember, in your ordered pair, this 6, 1, this is x, this is y. So I'm going to put 6 here and square it, 1 here and square it. I don't know b squared, but I know a squared. And now I only have one unknown here, and I'm going to solve for it. So I'm going to square the 6 and square the 1. So 36 over 9, 1 over b squared, and it equals 1. I now need to isolate b squared. Before I start moving things, I'm actually going to simplify the 36 over 9. I can make that a 4. Now, if you'd rather keep it a fraction, you can. I'm just going to go ahead and simplify it to a 4. Subtract the 4. Negative 1 over b squared equals negative 3. Now, at this point, to solve for b squared, you can either treat it as a proportion at a 1, or if you'd rather multiply both sides by b squared to get it out of the bottom of the fraction, and then you're left with negative 1 is equal to negative 3b squared. I need to isolate b squared, so I'm going to divide both sides by negative 3. Negative divided by a negative is a positive 1/3 is equal to b squared. So now I have my a squared and my b squared. So now I'm going to go plug it back in. So again, here's my original that I wanted to plug it into. So x squared over a squared, y squared over b squared, and it equals 1. Now, keep in mind that if you're taking an SAT or a PSAT, you might see an answer choice like this. If they're looking for the coefficients on x squared and y squared to be 1. Okay? You also see it where you don't want a fraction in a fraction, so they're going to take this 3 and move it to the top. So you'll probably also see your answer written like this. And this is what I would want to see. The 3y squared equals 1. Keep in mind there would have been a 1 here, but you're going to see it any one of these 3 answer choices. Yes?
So on the multiple choice, if our answer is the whatever over a fraction, you would want us to move it up.
Mm-hmm. Yeah. But keep in mind, like when you're taking the SAT, it could be left as the first one. It could be the fraction. All right. So just be aware that all 3 of these are equivalent. So just be aware of that. Okay, let's try the next example. We still have the center at the origin. The last 2 examples I do, I'm going to move the center, and we'll have our H and K in our formula. All right, so for this one, they're giving me a focus point. Again, remember the focus is on that same axis that the vertices are. So I can already see that the number is in the y spot. So the standard form that I'm going to be filling in is y squared over x squared. And then, I'm sorry, y squared over a squared minus x squared over b squared equals 1. Now, I can figure out my c value because, again, that comes from the focus. So my c value is the square root of 13, but c squared is equal to 13. Again, because they're giving me an asymptote, I'm going to pull out my a and b value, and I'm going to solve it like a proportion. Again, when the y squared is first, the asymptote is the plus minus a over bx. When the x squared's first, it's flipped. The b's on top. So again, this whole number 5, when I put it into fraction form, becomes 5 over 1. Now, I don't have any other a or b value, so this is sort of like that homework question I did the other day, number 23, where we're going to be plugging in an expression and not a number. So I'm going to go ahead and solve this proportion. A times 1 is equal to b times 5. So now I have what a equals. It's not a number, but this is what I've got to work with right now. So I'm going to go ahead and plug in to c squared equals a squared plus b squared. My c squared is the 13. My a, I know what that is, and then I'm going to square this term. And now when I square 5b, it becomes 25b squared. I now have like terms that I can combine and get 26b squared. Divide by 26. My goal is to isolate b squared. And now I have b squared is equal to 13 over 26. I can simplify this fraction to 1/2. Now remember, for your standard form, remember what we're always looking to fill in is a squared and b squared. So now I need to go back and do this formula one more time now that I have the value of b squared and c squared. So again, c squared equals a squared plus b squared. My c squared was 13. I don't know a squared, that's my last missing piece. And b squared is 1/2. Gonna subtract 1/2. I'm gonna actually turn this into improper fraction. I'm going to change it so it has a common denominator. So then I get 25 over 2 is equal to a squared. Now that I have a squared and b squared, I can plug them in. So again, y squared over a squared, x squared over b squared, and again, pull that fraction that's in that fraction to the top. So pull that denominator up. So the final answer here is going to be 2y squared over 25 minus 2x squared equals 1. Yes.
Can you go back to the formula for this one?
Yes. Again, if it helps you to draw a picture, let's do that. So if I sketch, yes.
Since the origin is in at 0, 0, how can you tell without drawing a picture?
Okay, we can get it from the asymptote, or we can do the midpoint formula here to find the center. So there's two different ways. You can draw the picture, find the midpoint by just counting the boxes. You could do the midpoint formula. Remember in the asymptote formula, remember it was y minus y1. And then in this case where it's a over b, so plus minus a over b, x minus x1. Remember this is the k, this y1, and this is the h. Now, be able to work with this asymptote. This one's been manipulated. This is how we left it yesterday in point slope. Notice that they've added or actually they added the 3 to the other side. So let me fix this one up so I can pull my center point out of it. Now on the test, it might even be put into slope-intercept form. And then you're gonna have to, undo it or graph it. So let me go ahead and fix this one. So they've actually taken the 3 that was over there with the y and they added it. So let me put it back. So then now it's y minus 3 equals plus or minus 7 x minus 4. So now here is my k, here is my h. So my center is at the order pair 4, 3. So this is my center point. Now another way I could have gotten it is finding the midpoint of the two vertices. I can also quickly graph them. So if I graph 1, 2, 3, 4, 1, 2, 3, 4, 5, graph the order pair 4, 5, and 4, 1, I can see that the midpoint of these two is the order pair 4, 3. So either way. Okay, now I also need to find the A value. Remember the A value is the distance from the center to the vertice. And I can see that in between 4, 3 and 4, 5, it's 2. I could just subtract 5 minus 3. Yes?
How would you find the foci? Like, if you don't have the, like, if you don't have the present, like, how would you find that?
I would have to find, I'm going to have to find A and B, and then I could plug it into the C squared. The C squared equals A squared plus B squared.
And the C squared is the foci.
Yeah, that'll be the distance. The C is the distance from the center to the focus. So you would adjust the center point based on that C value. Yes?
What is the B?
I'm going to find that in a minute.
No, like what, like just what?
Oh, in this case, it's just going to be coming from the formula. When it was the ellipsis, it was the distance from the covertice.
Okay, but like for B's, it's like just like the extra one?
Yeah.
Okay.
Okay, so now I'm going to use the slope that's in my asymptote to find my B value. Because I've already found A. A is the distance from the center to the vertices, so A is equal to 2. So A squared equals 4. Again, I'm going to use that proportion because I'm going to use this 7 from my asymptote. Because remember, for this equation, because it's vertical, I'm going to be doing A over B. And it's equal to 7 over 1. Now, this time I do have an A value that I can put into my proportion. But I don't have the corresponding B. So now I can cross multiply and divide and solve this proportion. So I'm going to multiply 2 times 1 and 7 times B. Before it was pretty because we could see that 1/2 and the equivalent fraction was 6/12. This one's going to become 7B equals 2. Divide by 7, and B is equal to 2/7. I don't need B, I need B squared. So I'm going to square the 2, square the 7. So B squared is equal to 4 over 49. Yes?
How do you get the 2 and the 7 over 1 equals 2?
Okay, so what I'm using is the slope from my asymptote. So this 7, and remember here is the point slope. So when the y squared term is first, the slope is a over b, okay? And then I just turned 7 into a fraction by putting 7 over 1. And then the 2 over b, I used this 2, and then I didn't know b. Okay, so now I have everything I need. I have my a squared, I have my b squared. So let's put it in. And I also have my h and k. So the formula that we're going to put it into is y minus k squared over a squared x minus h squared over b squared equals 1. So let's fill in everything we have. So it's y minus 3 squared. My a squared is 4. My h is 4. And my b squared is 4 over 49. Again, we're going to flip the 49 up here. So y minus 3 squared 4, 49, x minus 4 squared over 4 equals 1. Yes?
If you leave it down there, is it wrong?
Well, be aware, because it's a multiple choice test, be aware to look for both. Okay? Sometimes they may ask you to expect to have a coefficient in front of the x squared, y squared to be 1, so they would expect you to leave it like this. However, if they don't want a fraction and a fraction, then you would be expected to move that 49 up. Okay, so I've seen it on tests both ways. So just be aware that both of these are valid answers. Yes?
So if the question has like both these answers, what would you put as the answer?
If it had both, it wouldn't. It would probably say both A and B.
Alright.
Okay, it's going to have only one or the other. It won't have both. All right, one more example when the center is not at the origin. This one's a little simpler. So again, if you need a picture, my center is at the order pair positive 1, negative 2. I've got my vertice at 3, negative 2. And I've got my focus point at 4, negative 2. So this is telling me my hyperbola is going to look like that. So it's hitting the x-axis. So this tells me that I could fill in what I already have. So this is h, this is k. And because it's touching the x-axis, it's going to be x minus 1 squared. And then y plus 2, because it's a negative 2. And now I have to figure out what a squared and b squared are. Now I can already count my spaces away. So I can see that from black to blue, I can see there's 2 spaces. So my a value is 2. So a squared is 4. And then I can also count to find my c. And then I'm going to use this formula. So my C is black to red. So you can see from this order pair to this order pair, it's 3 spaces. So C is 3. So C squared is 9. So 9 is equal to 4 plus B squared minus 4. 5 is equal to B squared. So 5 goes here and it equals 1. And you're done. Okay, so the homework for this, yes, is 31 through 41 odd. Again, you might want to attempt it, and then that way if you do have questions, you can ask me tomorrow in class, because this homework is due on Friday. Okay, so that is it. Yes?